In this video we're gonna look into animation. In Blender almost everything can be animated. So for instance we can animate a light to create an animation like this one. Or we can animate the properties of the material to make an animation like this one. The purpose of both of these animations is to enhance the viewer's perception of certain small features of a terrain. So for this video you will be working with a new data set that we haven't been working with before. You will find them in the folder Dem for Animation. This is the data set that's also being used in the example animation, and it is a highly detailed LiDAR recording of an archaeological site, the Muro Tenente in southern Italy. It's a Iron Age defensive circuit. And due to the high resolution of the recording, it allows us to play with the visualization of small morphological features. So let's get started. So if you follow the previous videos, you're familiar now with the process of importing georeferenced digital elevation data into Blender. First we will delete the default cube, go to GIS, import georeferenced raster data. Go to the folder Dem for Animation, and here you will find two options. So if you have a very slow, weak computer, you choose the Muro Tenente Dem Clipped. It's a smaller version of the digital elevation model. And if you have a bit of a stronger computer, you choose the full one. So you probably know what your computer is capable of based on the previous videos. So we will choose Dem as a displacement texture, and otherwise we keep it the same way. Import it. As you see, we have the same problem as previous in the previous video. The digital elevation model, or the mesh that's created, is of relatively low resolution. And we know now why this is. This is because of a setting and the modifiers. So in order to create a higher resolution mesh, you simply add multiple multiple subdivisions on top of the already present one. Set it to simple and crank up the levels. And as you can see, this will load a while. Yes, and as you can see, it will reveal the defensive enceinte and the center excavation. So before we move on giving a material and color to this terrain, I want to talk a little bit more about some alternative visualization modes. As you have already seen in the previous video, here you can change the basic visualization or shading mode, as they call it in Blender. While we are in solid shading, we can also have multiple options. So rather, you can here also change the type of shading, which already can do a lot to the perceptibility of certain features on the terrain. Also the madcap one can be very useful. These are all used for modeling in order for the modelers to see their meshes better, and they can be used for us as well in a similar manner, because our aims are very similar to the modeler that wants to have a very good view on small details, mistakes, features of his or her models. So you can switch between studio lighting and so-called madcap, material capture lighting, and it gives you a whole range of options that you can explore. Another interesting way of visualizing your mesh is turning on cavity. Cavity is a type of rendering that enhances sharp features in the mesh. So in this case there are ridges, which are the sort of the higher parts, the edges, the things that stick out, and the valleys, the things that are deeper. And you can turn up the sharpness of this. And this is another very effective way to visualize details of a terrain. Alright, let's go colorizing our digital elevation model. So go to GIS, Node, Terrain Analysis. It creates the nodes as we've seen in the previous video. We just have to switch to viewport shading, or we can... No, we have to switch to viewport shading. So as you may remember, to change the color here, you have to go to the material settings on the right and open up the color ramp. And here you can add additional stops to change the location and the color. This time I leave you to this by yourself, as you already know how this sort of works, but try to vary with the distance between the colors, which can give you this kind of interesting effects. So just add a couple of stops, experiment with different types of color, and come back to me when you have something that you like. Alright, so even though we have a nicely colored plane, it looks a bit flat, and that's because it lacks shading, it lacks shadows, and that's because it lacks a light. Of course, we have the default lighting that's part of this shading mode that lights the entire surface equally, but we need a sunlight in order to cast shadows. So hit Shift. So hit Shift A and add a sunlight. Hit G and then Z in order to drag it up to the above the mesh, and after that we can turn on the rendered shading mode. If you still have cycles on, you can turn EV on if that goes quicker for you. So with the sunlight selected, we can drag the yellow ball to change the direction of the sun. We can also change the strength of the sun and go in top-down view. Now you can also, for instance, hit R to rotate the direction of the sun. And as you can see, this gives you already a little bit of the effect that I was looking for in the animation. This kind of light is most effective when it's under a very low angle. So we can even make the angle even sharper and rotate. So we're ready to animate something. As said before, in Blender it is possible to animate nearly every property of every object. So for instance, the movement of an object is very easily animated. So how does this process of animation work like? Well, to show you a very simple example, I will turn off the sun and turn on this point light that I have here, and I'm gonna animate its movement from the right side to the left side. So basically what you have to do is to work with keyframes. So keyframes are points in time in which the state of an object or property is recorded. I will show you how this works. So in order to add a keyframe on its location, because that's what we're basically going to do, we are going to animate its location from here to there, we have to open up this panel on the side, go to Item, and with the point light selected we can see here the location, and we want to animate the X location of this point light in that direction. So in order to add a keyframe, we just have to hover over the property that we want to animate and hit I. The property location turns green. Now that means it is keyframed. You can see this as well in the timeline below. If you do not have a timeline at the bottom of your screen and your screen looks like this, press on the little arrow here on the corner and then change this window to timeline. And these points in the timelines, these dots, these represent the keyframes. So the easiest way to animate the location of the lamp from here to there is to go to move the timeline to a frame in the future, then move the object you want to animate to the location where you want to animate it to, and then go here and hit I again. And now new keyframes are created at frame 250. So if we go back now in the timeline with this button, you see it jumps back to this keyframe where we created a keyframe on this location. We can hit play now, and you see the lamp starts to move over the surface. Alright, let's get back to the sun. Turn off the point light, turn on the sunlight. And in this case we don't want to animate the location, but we want to animate the rotation. And this basically is the same process. So make sure that at the beginning of the animation starts at 0 on the timeline. And then we can go into top-down view. We make a keyframe at this rotation by hovering over the rotation and hitting I. It takes a while. Yes, it made a keyframe. Now we can use the rotate tool or hit R to rotate the sun like a full 360. And well, we should have done this before. First move the timeline, then make the rotation, then hit I, then go back and hit play. And as you can see, we get a full rotation. So sometimes you may wish to change the properties, for instance the angle of the sun. In this case the angle of the sun is related to the rotation of the sun, so we can better delete the keyframes that are in here. So if you want to delete all the keyframes, we simply go right button on the fields that is containing the keyframe. So you can say here clear keyframes. So to make it the visualization better, I increase the strength of the sun and I increase the angle even more. So now we have a very good view of all the small morphological features that this terrain contains. So we go back and we do the same thing again with the animation. You can do this yourself. You also may wish to change the length of the animation. As you can see now, it only animates, or it plays the area between 0 and 250. It plays a maximum of 250 frames. If you want to increase the number of frames that are in the animation, you can do that over here. So it starts at 1 and ends at 250, and you can drag this field to make it as long as you want. And in fact, you can also drag keyframes. So if you want to make the animation go over a longer period of time, you can simply box select these keyframes and then hit G, like with moving object, and just move it to another location on the on the timeline. And this will drag out the same animation over a longer period of time. So it will basically make your animation slower. Okay, now we have animated the rotation of the sun. We also want to animate the change of the color of the terrain. So how to do that? Well, basically the same way as you animated the sun. Make sure you go back to 0 in the timeline, then select the material properties. And what we have to do now is to animate the position of these stops. So the position is of this one is 0.035. This is 0 and this is 1. So as you can see, if I move this stop to the right or to the left, the position changes. So we can animate this. So for instance, if we want to animate the current position of this stop, we hit I. And just to be sure, we also animate the other stops, because we will have to move those as well. Then I go to the end of my animation, which is at 458. I change these to something like this. So the red is replaced by the blue and then the green. And then while I'm here, I hit I for this keyframe, I for that one, and I for that one. Then I go back. It starts slowly and there it goes. So if you want to increase the speed of this animation, we simply select the last keyframes and drag them a little bit back. And we play it again. And as you may notice, this animation of the changing color of the terrain occurs at the same time as the rotation of the sun. So there's two things happening in this scene at the same time. When you're happy with your animation, the only thing that remains is to export the animation in a movie format. So how to do this? Well, the first thing that we have to do is to add a camera to record this animation. So Shift A and then camera. The camera is now somewhere over here, but I showed you already before in the previous video the trick to getting the camera to the point of view of where you are now. So we are going to record this animation from top down. So I'm going to go into this position, and with the camera selected, I go to view, align active camera to view. Now the camera doesn't see anything, it's because it's too far away from the landscape. So add this to 10,000 and there we go, we see it. So in this case we also may want to change the location of the camera somewhat. We're going out of camera view, and we also make the camera a little bit bigger so we can see it better in the viewport. So we go here, viewport display, and we make it 50 meters, and there we are. There we have our camera, and we get a toolbar. We moved a little bit to the right so it is better above. Yes, that's about right. Now we have to zoom out a little bit, and a good way to zoom in or out is to change the focal length of the camera. If you wish so, you can also change it to an orthographic perspective, but then you will have to change the scale a lot. This is a real top-down view of the camera. Oh, move it a little bit to the right. Go back into camera view. And we want to cover this entire area. That means that we have to change the resolution to a more square format. So we make the Y resolution a little bit higher. This is done in the output properties. We also I change the orthographic scale a little more, something like this. Alright, now we're ready to export the animation. So as discussed in the previous video, there's two rendering engines to be used when you're exporting animation or images. So I can simply go and use the current rendering engine, the Eevee one. However, the Cycles one will give you better results in terms of shadows. The Eevee shadows, as you have seen, are a little bit coarse. There are ways to improve the shadows in Eevee, of course. And this, you have to go to the sun and then go to the lighting settings, shadow, and well, first change 700. So as I had discussed in the previous video, there are actually two rendering engines, the Eevee one and the Cycles one. And now we've been working with Eevee because it visualizes faster in the viewport, but the quality of the renderings are slightly worse. You can see it, for instance, with the shadows here. They are a little bit coarse and pointy, while if we turn on Cycles, it takes longer. But the shadows and colors in general look a little bit better. Now there are ways to improve the shadow representation in Eevee. So we have to go to the render settings in Eevee, and then from this last list of render settings you go to shadows and then increase the cascade size. And basically Eevee sort of stores the shadow information on on maps, on texture maps, flat maps. So the larger this map is, the higher the resolution, so the higher the resolution of the shadow. So if we turn it up to 4096, we get already a better result. Alright, we're going back into camera view and play back our animation, and then last look if we're satisfied. Alright, so to set up the rendering, you have to go to Output Properties, and under Output it stores now in a temporary file, which you have to hit the folder and then make a new location, new folder, call it Animation, accept, and a file format. We don't want PNG because then it will output a series of PNG images rather than a video. We want an FF MPEG video, which is a nice format to share videos, light videos. Sort of the basic settings are alright. Before you hit the render button, there are two other things you have to take care of before you forgot. One of these things is that if you render it as it is, I will show you what happens. You get an image like this. This is not that the resolution is too low or that there is some kind of out of focus camera in use. No, this is because the digital elevation model was not put to the maximum levels of subdivision for the render. So go to this one here, to the modifier panel, and set the levels of subdivision to an appropriate level. Okay, that's the first thing. And then there's another thing. We had still a point light from the example animation from the beginning of this video in our scene. If you start rendering now, you will see that the point light will appear even though it is invisible. So click here, turn on the rendering restriction toggle, and make sure that it is out of the render. Now you're set, and you can start with your rendering. So render image one more time to check if there are no mistakes. Yes, everything seems fine. Now we're ready to render for real. Render animation. So now you have to wait. It has to render a few hundred images, so that may take a while. So grab a coffee or lunch or dinner or whatever you like, and return when it's finished. So if the process is really slow for you, as it is for me in this case, there's two things that you can do. You can simply forget about rendering the camera. You can go to View and then Viewport Render Animation. That will also work, and that will go a bit quicker. And another thing that you can do is to downgrade the resolution of the image. So for instance, the X and the Y dimensions of the output properties here. So a quick way to do this is you can add mathematical equations in here. So we add divided by 2, and this one also divided by 2. It will just lower the resolution. It will not change the size of the camera. And with this resolution you can try to render again. So with this you've come to the end of the last video of this online course on 3D visualization of GIS data inside Blender. I hope you learned something that you can use in your own work, or that you enjoyed it. Of course there is way more to learn about lighting, about creating materials, about animating in Blender. But I leave further exploration of the amazing possibilities of Blender up to you. For now, thank you for your attention and effort, and see you next time.